if you need some help with factoring, I suppose I'm your guy. But if you need a complete reteaching, this is not going to do that. So in calculus, you need to be able to factor any polynomial that is factorable. Not all polynomials are factorable, using a variety of techniques. And I'm just going to walk you through some examples, like I would in class, to remind you of things you used to be good at and hopefully still are. Okay, just a common error to watch out for. You know, a lot of my students think they read instructions, and they might, but most of these are not going to have an equal sign. In fact, if you're not given an equal sign, don't create one. Converse, if you are given an equal sign, don't destroy it. You know, if you create an equal sign, especially on something like factoring, you're going to end up with the wrong result. You're going to end up with like, hey, x is equal to something, because instead of factoring, you ended up finding the root. So just watch out for that. You know, it's kind of attention to detail, looking at what you wrote on the previous line rather than guessing what to do. Okay, x cubed minus 5x squared minus x plus 5. Now, not, I don't know, not like the Algebra 1 quadratic stuff. So I see an x squared and an x cubed. And the coefficients are 1 and negative 5. And over here, an x and a 5 also differ by a degree of 1, like this is 5x to the 0, and their signs are opposite. So I think I can factor by grouping. So this first pair, x cubed minus 5x squared, I can factor out an x squared, and I'd be left with x minus 5. And so out of negative x or minus x plus 5, I also want to get another common x minus 5. So I factor out a negative 1. I don't know why people don't see it this way, but now you actually just have two terms. And both of those terms have a common factor of x minus 5. So we can factor out that x minus 5. And out of the first term, we're left with an x squared. In the second term, we're left with a minus 1. Okay, so that looks better. To factor means to rearrange such that things are being multiplied. The pieces that you're multiplying together are called factors. X minus 5 is a linear factor. We can't factor that more. X squared minus 1, though, you should recognize that. Doesn't really matter if you know what it's called. That's called a difference of squares. X squared is a square, 1 is a square. They're subtracted, difference of squares, which factors down to x minus 1, x plus 1. As long as you see x squared minus 1, factor it into x minus 1 times x plus 1, we're good to go. So that is a pretty good factorization. Okay. When you see something like x to the 4th minus 2x squared minus 15, oh man, you know, that might be easier if instead of x to the 4th, that was like x squared. And instead of minus 2x squared, that was minus 2x. And so we can kind of do that. We can rearrange, because really all we're looking for is factors of minus 15 or negative 15 that add to negative 2, which is, of course, minus 5 and plus 3. So what we're going to do, and you don't have to, but if you need to see the structure, we can do u substitution. So if we temporarily define u, this replacement, as x squared, you might be able to see the structure a little bit easier. So x squared squared is x to the 4th, so we can write u squared in place of x to the 4th. Instead of minus 2x squared, we can write minus 2u minus 15. Because this now feels like an easier quadratic. Well, something squared minus 2 times that something minus 15. So we just want, well, u minus 5 and u plus 3 as those linear factors. Now, of course, we're not done. We made up u equals x squared, so we need to replace each of these u's with x squared plus 3, and x squared minus 5 are the factors. Now, x squared plus 3, I suppose we could factor, but that would be involving some i's, right? We'd have some complex numbers, which we don't really deal with in calculus. AB, how about that? X squared minus 5, though, we can factor as a difference of squares. Apparently, I didn't do that, though, so we'll deal with that in a later example. Okay, so what do we see here on x to the 6th minus 26x cubed minus 27? There are a couple of ways to go, but what I see is, well, x cubed, it's kind of like the last one. right? Imagining, well, what if this was something squared minus 26 times that something minus 27? Well, then it would be, well, that stuff minus 27 and that stuff plus 1. And hopefully you can see that. If not, go back and try it again. Just write u equals x cubed and do a very similar thing here, and you'll have u squared minus 26u minus 27. Anyways, can we factor x cubed minus 27? Can we factor x cubed plus 1? Yeah, sum and difference of cubes. Hopefully you remember that formula. It's a common one to forget. You should at least recognize x cubed minus 27. And usually people can remember, well, then my first thing is x minus 3. And what you should know is, whatever we're about to write times x gives us x cubed. So it's got to be x squared. And negative 3 times, this constant I'm about to pop up should give us negative 27. So we know that's plus 9. And turns out it's a 3 times x in the middle. Okay. We may have to do a little bit more practice on that one, but it's a formula, memorize it, know it, whatever. X cubed plus 1 factors into x plus 1 times, well, it's going to be x squared at the beginning, plus 1 at the end, and what goes in the middle? It's a minus x. Now you can check, obviously x plus 1 and x minus 3 are linear factors. They cannot be factored further. X squared plus 3x plus 9. The only way to get some common stuff here is like x plus 3, x plus 3, x plus 9, x plus 1, neither of which work out with a 3x. Likewise over here, maybe x squared minus 2x plus 1 would be factorable, but not x squared minus x plus 1. Ooh, 4 terms. What do we see? Well, x to the 6th and x to the 4th differ by a degree of 2. X squared and 32 also differed by a degree of 2, like x to the 0. The signs of x to the 6th and 2x to the 4th match. They're both positive. The signs of negative 16x squared and negative 32 are both negative, so they match. We can deal with that. And then, what's the difference in coefficients? Well, the second one here is twice as much, and 32 is twice 16. So I think we can factor by grouping. All right, so I forgot to change a little plus there. I bet they're all going to be wrong. Okay, so what would we factor out of the first pair? X to the 4th, and we'd be left with x squared plus 2. And you can see x to the 4th times x squared is x to the 6th power, and x to the 4th times 2 is 2x to the 4th. So out of the second pair, we want to factor out, well, we want to be left with, oh, that was supposed to be negative. I see. Okay. Oh, sorry. I was not thinking. I should have been smarter. Okay. Out of that second pair, let's see, we are going to factor out a negative 16, because then we're left with another x squared plus 2. We have a common x squared plus 2 to factor out. And then x squared plus 2, we don't want to deal with complex numbers, but we can factor x to the 4th minus 16 into x squared plus 4, x squared minus 4, but then we have to factor that x squared minus 4 into x plus 2 and x minus 2. All right, here we go. Let's see if I can get my pointer back. I don't want that. Okay. Well, what do we see here? X to the 4th minus 13x squared plus 40. And so this is another one. We'll try to do it without, where we could write this u is equal to x squared, but we can just think something squared minus 13 times something plus 40. So we want factors of 40, same sign that add to 13, and that's minus 5 and minus 8. So we can rewrite this. I don't know where my parentheses went. Apparently they're not coming back. X squared minus 8 is the first factor, x squared minus 5 as the second factor. Now earlier I said we can factor things like this further. Even though 8 isn't a perfect square, we do know a number to square to get 8. And that's the square root of 8, or 2 square root of 2. So we can rewrite x squared minus 8 as x minus the square root of 8 times the other factor, x plus the square root of 8. Likewise, x squared minus 5, we can factor into x minus the square root of 5 times x plus the square root of 5. All right, what do we see here? X to the 9th minus x to the 6th minus x cubed plus 1. Well, at first it doesn't feel like I'm going to be able to do anything, but maybe I can. Let's see. X to the 9th and x to the 6th, those are off by a power of 3, like x to the 9th is x cubed more, times as many. And x cubed, x to 0, that's off by a power of 3. X to the 9th and negative x to the 6th are opposite signs, both have a coefficient 1. Negative x cubed and 1, both have a coefficient of 1, opposite signs. So I think I can factor an x cubed. Oh no, I can factor an x to the 6th out of the first pair. And I factor out a negative 1 out of the second pair because I want a second x cubed minus 1. Once we factor x cubed minus 1 out, we're left with x to the 6th from the first factor and minus 1 from the second factor. Hopefully you realize those are both differences of cubes. So we'll factor x cubed minus 1 into x minus 1 times x squared plus x plus 1. Right? This x squared is, x times x. This 1 is 1 times 1. And this x in the middle, well, that's x times 1. You don't have to worry about the signs. The signs are something different. How about that? Oh, man. Where do these parentheses keep going? Okay. Anyways, likewise over here, x squared minus 1. X squared times x squared is this x to the 4th. 1 times 1 is this 1. And 1 times x squared is this x squared. The acronym SOAP tells you the signs like this. This is going to be the same sign minus, same, S, SOAP. The opposite, and then always positive at the end. Sorry, my stylus isn't with me right now, so I have to use a mouse. SOAP, same, opposite, always positive. Super ugly. Hopefully you can see. Let's get rid of that. That's super ugly. That x squared minus 1 can be further factored into x minus 1 and x plus 1. Apparently I didn't do the animations right, so let's call that for a day and you can just start on your own.